Electromagnetic effect is effect in which the shifting of pi electrons takes place. Shifting of pi electrons takes place. Okay. Shifting of pi electrons takes place towards the attacking reagent. Pi electrons takes place towards the attacking reagent. Electromagnetic effect is effect in which the shifting of pi electrons takes place towards the attacking reagent. So if you take C double bond C plus H plus, what happens here? Okay, the pi bond is shifted towards the H plus. The pi bond is shifted towards the H plus, and thereby what you are going to get C. And you are going to get like this. And you are going to get the positive charge. You are going to get the positive charge. So this electromagnetic effect, it can be seen in which electron students? Pi bonds, pi electrons. That means electromagnetic effect is observed in the double bonded compounds. It is observed in the which compound students? It is observed in the double bonded compounds. Electromagnetic effect is observed in double bonded compounds, whereas inductive effect is observed in the single bonded compounds. Single bonded compounds. Electromagnetic effect can be seen in the double bonded compounds. That means pi electrons is shifted towards the attacking reagent. So this is the attacking reagent, students. This is the attacking reagent. Okay, the pi bond is shifted towards the attacking reagent, and what we are going to get this, we are calling it as plus E effect. Okay, attacking reagent, you are going to get the plus E effect. Understood? Electromagnetic effect is the effect in which the shifting of electrons takes place towards the attacking reagent. Right. Next. Yes, students, next class also, botany sir, today sir is not there, so I will take sir class. Okay. Very important student, today's class, don't miss. Electromagnetic effect, so this is, we are calling it as plus E effect. How the inductive effect is of two types, like that electromagnetic effect is also of two types. So this is plus E effect. This is which E effect? Plus E effect. This is plus E effect. Okay, the pi bond is shifted towards the H plus, and you are going to get the carbocation, and you are going to get like this. So this we are calling it as plus E effect. This we are calling it as plus E. Have you understood, students? Okay. Okay, students, have you understood what is electromagnetic effect? Electromagnetic effect is the effect in which the shifting of pi electron takes place towards the attacking reagent. Inductive effect means it will take place in the single bonded compounds. Electromagnetic effect will take in the pi bonded compounds. Understood, students? Next we have negative electromagnetic effect. What is meant by negative electromagnetic effect? Next, negative electromagnetic effect. Next one. Just a minute, students. Electromagnetic effect in which the shifting of pi electrons takes place towards the attacking reagent. This we are calling it as electromagnetic effect. Next, negative electromagnetic effect is there, students. Negative electromagnetic effect. How positive electromagnetic effect is there? Like that, we have negative electromagnetic effect. Negative electromagnetic effect that we are calling it as minus E effect. Negative electromagnetic effect that we are calling it as minus E effect. What is this negative electromagnetic effect? Let us discuss this negative electromagnetic effect. It is an electromagnetic effect in which it is an electromagnetic effect in which the shifting of electrons takes place away from the attacking region. Okay. It is an electromagnetic effect in which It is an electromagnetic effect in which the shifting of electrons. It is an electromagnetic effect in which the shifting of electrons takes place away from the attacking reagent. Okay, electromagnetic effect, negative electromagnetic effect is the effect in which the shifting of electrons takes place away from the attacking reagent. That we are calling it as negative electromagnetic effect. Carbon-carbon double bond. Okay, plus this is attacking reagent, students. Here Cn minus is the attacking reagent. Here Cn minus is the attacking reagent. Understood? So what happens here? The pi bond, how the pi bond is shifted. So the Cn minus is going to attack this one. The Cn minus is going to get attacked like this. Okay, the Cn minus is attacking like this. The pi electrons, here the pi electrons will be shifting away from like this. The pi electrons is shifting away from the attacking reagent. The pi electrons are shifting away from the attacking reagent. In the previous example, you see, students, the pi electrons are shifting. How it is shifting? It is shifting towards the attacking reagent. The pi electrons are shifting towards the attacking reagent. But in this example, so this we are calling it as plus C effect. In minus C effect, what happens here? The pi electrons are shifting away from the attacking reagent. It is shifting away from the attacking reagent. It is shifting towards the carbon, students. In fact, the pi electrons are shifting towards the carbon. Understood? The pi electrons are shifted towards the carbon here. And thereby what you are going to get here gives rise to, so here C minus, okay, and you are going to get the Cn. You are going to get the Cn like this. So it is an negative electromagnetic effect. It is an electromagnetic effect in which the shifting of electrons takes place away from the attacking reagent. This we are calling it as negative electromagnetic effect. Students, have you understood the difference between positive electromagnetic effect and negative electromagnetic effect? Positive electromagnetic effect and negative electromagnetic effect, both it will take place in the pi bonded compounds. Okay, both it will take place in the pi bonded compounds like alkenes. So this electromagnetic effect is of two types. One is partial electromagnetic effect in which the shifting of pi bonds will takes place away towards attacking reagent, that we are called as partial electromagnetic effect. If the shifting of pi bonds is taking away from the attacking reagent, that we are calling it as negative electromagnetic effect. Have you understood, students? Is it clear?
Okay.
Shall we go to the next other topic, that is mesomeric effect. Mesomeric effect or resonance effect. Next topic is mesomeric effect or resonance effect. Let us discuss the next one, that is mesomeric effect or electromagnetic. Mesomeric effect. Next one is mesomeric effect, or the other name for this one is resonance effect. Mesomeric effect or resonance effect. The next one is. Let us discuss what is meant by mesomeric effect or resonance effect. Okay, so mesomeric effect or resonance effect is nothing but the polarity produced in a molecule due to interaction of two pi bonds. It is okay. The polarity produced in a molecule. The polarity produced in a molecule. Okay, the polarity produced in a molecule due to interaction of two pi bonds. Due to interaction of two pi bonds. Due to interaction of two pi bonds. Okay, or between the pi bond and lone pair of electrons. Or between the pi bond and lone pair of electrons. Pi bond and lone pair of electrons in a conjugated system. In a conjugated system, okay, is called resonance effect or mesomeric effect. Is called resonance effect or mesomeric effect. Is called resonance effect or mesomeric effect. What is a mesomeric or resonance effect? Means here the polarity produced in a molecule. The polarity means formation of charges. What is polarity, students? Formation of charges, that we are calling it as polarity. Formation of charges. Okay. The polarity produced in a molecule due to interaction of two pi bonds. Due to interaction of two pi bonds. Understood? So the polarity is produced in a molecule due to interaction of pi bonds. That means the formation of charges will take place due to interaction of two pi bonds or between the pi bond and the lone pair of electrons. Okay, in a conjugated system is called resonance effect or mesomeric effect. Or between the pi bond and lone pair of electrons is called resonance effect or mesomeric effect. So what is mesomeric effect, students? So it is nothing but that is the polarity produced in a molecule due to interaction of two pi bonds or between the pi bond and lone pair of electrons in a conjugated system is called resonance effect or mesomeric effect. I will write this resonance effect and mesomeric. First, these are also two types are there, students. One is plus R effect, other is minus R. How electromagnetic and these are the inductive effect, like that here also. Okay. Attacking reagent means the species which is going to attack the substrate molecule. In the last class, I said what is substrate? Substrate molecule means the molecule which takes part in the chemical reaction that we are calling as substrate. Attacking reagent means the reagent which attacks the substrate molecule that we are calling it as substrate. I have given definition, students, in the last class only. What is meant by substrate and what is meant by reagent? Species which attacks the substrate in order to get the product is called reagent. What is substrate? Substrate is nothing but the molecule which is taking part in the chemical reaction that we are calling a substrate. What is meant by reagent? The species which attacks a substrate in order to get the product that we are calling it as a reagent. Understood? Conjugated system. Conjugated system means alternate single and the double bonds. I will show you what is meant by conjugated system. Conjugated system means like this. Okay. Alternate single and double bonds like this. A compound having alternate single and double bonds that we are calling it conjugate system. Example, benzene. Okay. Example is benzene. Okay. In benzene, okay. Please unmute yourself, students. Don't. Please mute yourself, students. Okay. Don't disturb the class, students. Please mute yourselves. Okay. Conjugate system means like this: alternate single and double bonds. That's we are calling it as conjugate system. Alternate single and double bonds. This we are calling it as a conjugate system. Alternate single bond, double bond, single bond, double bond. This we are calling it as conjugate system like this. Okay, this we are calling it as a conjugate system. If a molecule containing alternate single and double bonds, that we are calling it as a conjugated system. Understood, students? So the polarity, that is formation of charges produced in a molecule due to interaction of two pi bonds or between the pi bond and lone pair of electrons in a conjugate system, is called resonance effect or mesomeric. Is it clear, students? Have you understood what is mesomeric effect? Like electromagnetic effect and inductive effect, it is also classified into two types. One is minus R effect, other is plus R effect. Negative resonance effect, other is positive resonance effect. Understood? Benzene is example one. Conjugate system is benzene, 1,3 butadiene, all these are the examples. Alternate single and double bonds where you can see that we are calling it as conjugated system. Understood? Next. So here, what you are going to get, that is next one is negative resonance effect. Or you can take first positive resonance effect, students. Positive resonance effect. Positive resonance effect. Positive resonance effect, this we are calling it as plus R effect. This we are calling it as plus R effect. Okay. So it is a resonance effect in which the displacement of electrons takes place away from the substituent groups. So it is a resonance effect. Positive resonance effect is nothing but it is a resonance effect. It is the resonance effect in which the displacement of electrons takes place away from the substituent group. Takes place away from the substituent group. It is a resonance effect in which the displacement of electrons takes place away from the substituent group attached to the conjugated system. Attached to the conjugated system. It is a resonance effect in which the displacement of electrons takes place away from the substituent group attached to the conjugated system. Okay. For example, aniline. Sample aniline. Okay. It is a resonance effect in which the displacement of electrons takes place away from the substituent group attached to the conjugated system. Example, aniline. Okay. So this is aniline, students. So this is a benzene ring. Benzene ring attached to the NH2. This compound, what we are calling it as aniline. NH2 group attached to benzene ring, this we are calling it as aniline. Nitrogen is having the lone pair of electrons. Here nitrogen is having the lone pair of electrons. Okay. These lone pair of electrons. Okay, this lone pair of electrons. So this is the sp2 carbon. sp2 carbon. So it will pull the lone pair of electrons like this. It will pull the lone pair of electrons like this. So when the lone pair of electrons are pulled, what happens here? You are going to get a double bond between carbon and nitrogen. What you are going to get? Double bond. See the cursor, students. So you are going to get the double bond. I will show the double bond in the next structure. So when you are going to get the double bond, what happens? So this pi bond is shifted. Okay, this pi bond is shifted towards outside, like this. This pi bond is shifted like this carbon, and you are going to get a resonance structure. You are going to get the resonance structure like this. You are going to get a resonance structure, and you are going to get a double bond here, because the lone pair of electrons has came between carbon and nitrogen. So thereby a new bond is formed between carbon and nitrogen. You are going to get a double bond, and this pi bond is shifted outside. This pi bond is shifted towards outside, and you are going to get the negative charge here. You are going to get the negative charge. Okay, and inside the double bonds will be like this. Again, what happens? This negative charge will enter into this system, and what happens? This pi bond is shifted towards outside. What happens? Again, the pi bond is shifted towards outside like this, and we are going to get like this. A new bond is formed here at this position, and here NH2 plus, you are going to get NH2 plus. Here also NH2 plus. After lone pair of electrons shifted, you are going to get plus charge, and you are going to get negative charge here. Again, what happens here? So again, the negative charge will enter into the ring, and a new bond is formed at this position, and you are going to shift the electrons like this. The electrons are shifted like this, and we are going to get like this. Okay, double bond NH2 plus. You are going to get the negative charge here, students. You are going to get the negative charge like this, and like this we are going to get. So this we are calling it as resonance structures. All these resonance structures we can write in one structure like this. NH2, this is minus like this. Students, have you understood how we got this structure? First, what happens? The lone pair of electrons is transferred towards the ring. The benzene ring carbons all are sp2 carbons, more electronegative carbons. It will pull the lone pair of electrons. Thereby, a new bond is formed between carbon and nitrogen. Listen carefully, students. And when it is a new bond is formed, this carbon is going to get the valency 5. So this pi bond is shifted outside, and you are going to get negative charge. Again, the negative charge is shifted inside the ring. Again, this pi bond is coming outside like this, and you are going to get again this negative charge is shifted inside the ring. Again, this pi bond is going outside. You are going to get the new negative charge. Like this, the charge is transferred, students, from this position to this position. Okay, the charge is transferred from that position to that position, and you are going to get the negative charge at two ortho positions and one para positions like this. This we are calling it as positive resonance. Is it clear, students? If you have any doubts, you can ask, students. You can unmute yourself and you can ask if you have any doubts. Please. Is it clear, students, how we got the positive resonance effect? Understood? Last structure is the resonance hybrid, we are calling it. I will show you, students. Resonance hybrid means, so here, this all four structures we are representing in one structure. That means how a child can represent father and mother. If you take a child, in that child, the child is having both the features of mother and father. Like that, if you take a resonance hybrid, the last structure we are calling it as resonance hybrid. This we are calling it as resonance hybrid. In this resonance hybrid, you can see all the four structures. You can see the all four structures. All four structures, if you are writing in one structure, that we are calling it as resonance hybrid. Hybridization like this. So here in the second structure, negative charge we have shown here. That negative charge is here. The third structure, negative charge is shown here. Here that we have shown here. And in fourth structure, the negative charge is here. Here we have shown. That means all the four structures we are placing in one structure, that we are calling it as resonance hybrid. That we are calling it as resonance. So this is about the resonance effect. It is a resonance effect in which the displacement of electrons takes place. So here the electrons are displacing. The electrons are moving, okay, from the substituent group. So this is the substituent group. So this is the substituent group. This is the substituent group. Electrons are moving from the substituent group towards the benzene ring. Electrons are moving towards the substituent group towards the benzene ring. Okay, so that we are calling it as positive resonance effect. Example. Understood. Still, students, any doubts if you have? If it is clear, means I will go for the negative resonance effect. Any doubts, students? You can ask, students. Abhay, any doubts? Ananya, Archit, Chandana, Mehak, Mubashirin. Sujan. Is it clear, right, students? Don't go away from the meeting room, students. Okay. This is about the positive resonance effect. Next, let us discuss about the negative resonance effect, students. Next one is negative resonance effect. What is meant by negative resonance effect? Negative resonance effect, that we are calling it as minus R. Negative resonance effect, this we are calling it as minus R effect. Okay. It is a resonance effect in which the displacement of electrons it is a resonance effect in which the displacement of electrons takes place towards the substituent group. The resonance effect in which the displacement of electrons takes place, okay, takes place towards the substituent group, takes place towards the substituent group, Understood? So that means if you take example nitrobenzene, example is nitrobenzene, right? Let us draw structure of the nitrobenzene. So this is the benzene ring. So this NO2 group is attached to that, we are calling it as nitrobenzene. Okay. N single bond O, double bond O. Okay. Now here, what does it take? Here positive charge and here negative charge. So here what happens here? Shifting will take place. Shifting of the pi electrons. Nitrogen is having positive charge right here. So it will attract this pi bonds like this closer towards it. And thereby what you are going to get? You are going to get the resonance structure like this. Okay. And you are going to get the resonance. Whenever the bond has been shifted, a new resonance structure you are going to get students. So this is a new resonance structure you are going to get. You are going to get double bond here, N plus O minus double bond O. And here this carbon is losing the electron now, so you are going to get the positive charge. Here you are going to get the positive charge. Understood? Now what happens here? In order to stabilize this charge, this pi bond is shifted towards like this. And thereby what you are going to get? You are going to get the new resonance structure. Whenever the bond is migrating, you are going to get a new resonance structure. And this carbon is electron deficient now. Whichever the carbon has become electron deficient, that electron deficient carbon we are showing with the positive charge, because this carbon has losing the pi electron. So we are showing with the positive charge. So it is an electron deficient compound. And thereby what you are going to get? Double bond N plus O minus double bond O. Again what happens? This electrons will transfer towards this. And what you are going to get? Okay. You are going to get a compound like this. And this carbon is going to become the electron deficient. We are showing with a positive charge. Double bond N, positive O minus double bond. So all these four structures we can represent in one structure that we are calling it as resonance hybrid. So let us draw a resonance hybrid, students. So this is a resonance hybrid. So here which charge is moving? Positive charge is moving. Here which charge is moving, students? Here positive charge is moving. So we'll show the positive charge like this. Okay. And double bond N plus O minus double bond O. So this is resonance. This we are calling it as resonance hybrid. Understood, students? So how the charge has been moved and how we are going to get the positive charge, how we are going to get the resonance effect. So this is a negative resonance effect. What is the difference between negative resonance effect and positive resonance effect? In negative resonance effect, we can see what we can, that is negative charge is moving around the benzene ring. Negative charge is delocalizing. Moving means we are saying it as delocalizing. Negative charge is delocalizing around the benzene ring. In positive resonance effect, which charge is in the minus R effect, which charge is delocalizing? That is positive charge is delocalized. Okay, so you should not confuse negative resonance effect means negative charge is delocalized. Positive resonance effect means positive charge. No, not like that. So here, why we are saying positive, why we are saying negative means positive, why we are saying means because here the displacement of electrons is taking place away from the substituent group. When the electrons are moving away from the group to the benzene ring, that we are calling as positive. Giving, if the electrons are given by the substituent group to the benzene ring, that we are calling it as positive. Okay. In positive resonance effect, which charge is delocalizing? Negative charge is delocalizing. And if you take in a negative resonance effect, here the movement of electrons takes place from the benzene ring to the substituent group. So when the movement of electrons is taking place from the benzene ring to the substituent group, so what happens here? So which charge is going to get positive charge? Here the positive charge is delocalizing. Understood, students? Is it clear? In second step, okay. In second step, it is accepting electron. How can it get positive? Okay, good question you have asked here. So here, because the nitrogen is having the valency of, just a minute, students. So here I have done some small mistake here. Just a minute. Okay. So here I have done just a mistake. Here, if you see, students, here this pi bond is shifted towards the oxygen, and oxygen is going to get the negative charge. Oxygen is going to get which charge? Negative charge. Negative, negative, and negative. So here the oxygen is going to get the negative, negative, negative charge. Understood? So here, what happens here? Exactly. Because the nitrogen is having the valency of 3 students. Nitrogen is able to form how many bonds? 3 bonds. If it is forming one more bond extra, then we are showing with the positive charge. Then we are showing with the positive charge. Nitrogen, why we are showing with the positive charge means because nitrogen is able to form 3 bonds, but here 4 bonds are there. That's why we are showing with the positive charge. Understood? Is it clear, students? Have you understood? So nitrogen can able to form only 3 bonds. If it is forming 4 bonds means we have to show positive charge. Okay, because it can able to form 3 bonds. If it is forming one more bond extra means, so if it is forming one more bond means, so we have to show positive charge. Understood? Is it clear, students? Ananya, is it clear? I have understood between positive resonance effect as well as the negative resonance effect. Is it clear, students? So let us once again, we'll see from beginning onwards what we have discussed. what is meant. So in today's class, we have discussed electromagnetic effect. Electromagnetic effect means this type of effect can be seen in the double bonded compounds. Here, shifting of pi electrons takes place. Shifting of electrons takes place towards the attacking reagent. This we are calling it as electromagnetic effect. So here, the alkene, okay. So the pi bond is shifted towards the H plus. The pi bond is shifted towards the H plus attacking reagent, and thereby you are going to get the positive charges. So this we are calling it as electromagnetic effect. Carbon is going to get the positive charge. Okay. So this is of two types. One is a plus C effect. In plus C effect, the pi bond is shifted towards the attacking reagent. Electromagnetic effect is the effect in which the shifting of pi electron takes place towards the attacking reagent. If the pi bond is shifted towards the attacking reagent, that we are calling it as plus C effect. And what is minus C effect? It is an electromagnetic effect in which the shifting of pi electrons takes place. Shifting of pi electrons takes place away from the attacking reagent. Shifting of pi electrons takes place away from the attacking reagent, that we are calling it as negative electromagnetic. Okay. Next one we have, what is the mesomeric effect or resonance effect? The polarity, that is formation of charges produced in a molecule due to interaction of two pi bonds or between the pi bond and lone pair of electrons in a conjugate system, is called resonance effect or mesomeric. What is mesomeric effect or resonance effect? Nothing but the polarity, that is formation of charges, okay, takes place in a molecule due to shifting of interaction of two pi bonds. Okay, so polarity means formation of charges. Okay, formation of positive and negative charges, that we are calling as polarity, or just simply formation of charges. The polarity produced in a molecule due to interaction of two pi bonds. So when two pi bonds are interacted, the polarity is formed. Or the interaction between lone pair of electrons and pi bond in a conjugate system is called a resonance effect or mesomeric effect. It's called resonance effect or mesomeric effect. Understood? So conjugate system means example benzene. Next, positive resonance effect. These are of two types. This resonance effect are of two types. Positive resonance effect means the shifting of lone pair of electrons towards the substituent group, from substituent group towards the benzene ring, that we are calling it as positive resonance effect. The displacement of electrons takes place from the substituent group to the benzene ring. From substituent group to the benzene ring, or substituent group to the conjugate system, that we are calling it as positive resonance effect. In positive resonance effect, which charge is delocalizing? Negative charge. And in negative resonance effect, what is negative resonance effect? It is a resonance effect in which the displacement of electrons takes place. Displacement of electrons takes place from the ring towards the substituent group. From the ring towards the substituent group. From benzene ring towards the substituent group, that we are calling as negative resonance effect. Example, nitrobenzene. Is it clear, students? Till here, is it clear? Next, let us go for the next one, that is hyperconjugation. Okay, next let us go for the hyperconjugation. Next effect, the last one is hyperconjugation effect, students. Next one is hyperconjugation. What is hyperconjugation? It is a special type of electromagnetic effect which involves delocalization of sigma electrons of the CH bond of an alkyl group attached to an atom of unsaturated system, or attached an atom with the unshared p orbital. Okay. Hyperconjugation involves the hyperconjugation involves the hyperconjugation involves the that is hyperconjugation involves the delocalization of sigma electrons, delocalization of sigma electrons of the CH bond of the CH bond of an alkyl group of the CH bond of an alkyl group directly attached to an atom of unsaturated system or with the unshared p orbital. Example, let us discuss the hyperconjugation of ethyl cation. Example, let us discuss hyperconjugation of ethyl cation. Hyperconjugation of ethyl cation, students. So let us take the H, 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 okay, carbon H, H. This is the positive charge. What you are going to get here? So here, this carbon is having a positive charge, students. So this is which carbon, students? This is alpha carbon. This we are calling it as alpha carbon. The carbon which is attached beside the carbon with positive charge, that we are calling it as alpha carbon. Okay. So alpha carbon is the carbon which is attached to the carbon which is having positive charge. Okay, that we are calling it as alpha carbon. What is alpha carbon, students? The carbon which is attached beside the carbon with positive charge, that we are calling it as alpha. That we are calling it as alpha carbon. Understood? Now what happens here? In order to get stability, what happens here? So, okay. So this alpha carbon is having 3 alpha hydrogens. All these are the 3 alpha hydrogens. This first alpha hydrogen, second alpha hydrogen, and this is third alpha hydrogen. So that means if alpha carbon is having 3 alpha hydrogens, means we are going to get how many hyperconjugated structures, friends? 3 hyperconjugated structures. Suppose if alpha carbon is having, that is, if 5 alpha hydrogens means, so you are going to get the 5 hyperconjugated structures. So if there are 6 alpha carbons are there, means you are going to get 6 alpha hyperconjugated structures. Right now we have 3 alpha hydrogens. That means we are going to get 3 hyperconjugated structures. We are going to get 3 hyperconjugated structures. Understood? Let us draw the 3 hyperconjugated structures. Carbon, double bond. Okay. H here, H and H. Hydrogen with positive charge here. What you are going to get? Hydrogen with positive charge. Understood? Next. Now this bond is going to get shifted. Second CH bond is going to get shifted. Now second CH bond is going to get shifted. And hydrogen with positive charge, you are going to get H. Double bond C, H, H. Now third CH bond is going to get shifted. What you are going to get? H, H. This we are calling it as hyperconjugation. This we are calling it as hyperconjugation. Hyperconjugation involves the delocalization of sigma electrons. It involves the delocalization of the sigma electrons of the CH bond of an alkyl group. The CH bond of an alkyl group. What is hyperconjugation? It involves the delocalization of sigma electrons of the CH bond of an alkyl group, that we are calling it as hyperconjugation. So here the CH bonding, okay, of an alkyl group will undergo delocalization. This we are calling it as hyperconjugation. It involves the delocalization of sigma electrons of the CH bond of an alkyl group. This we are calling it as hyperconjugation. Hyperconjugation of ethyl cation, you can see, students. First CH bond is going to donate, and you are going to get a new carbon-carbon double bond. Okay. Next, in the next structure, the second CH bond is going to get shifted, and you are going to get a new bond between carbon and carbon. You can see carbon-carbon double bond, and the H is going to get the positive charge. And then the third hyperconjugated structure, the third CH bond is going to get shifted, and you are going to get a new double bond between carbon-carbon, and you can see H+. Understood? So this is about the hyperconjugation. This is about the hyperconjugation. Any doubts, students? You can message in chat box. Please don't go away from the meeting room, students. Very, very important. Today's class is very, very important, students. Is it clear? You can unmute yourself and you can ask students if you have any doubts. I will give 5 minutes time. Okay, just I will give 5 minutes time, students. You can unmute yourself and you can ask any doubts. Feel free to ask doubts, students. Don't think about other students. Okay. Don't feel insecure. Ask doubts. Abhay, if you have any doubts, you can ask. Ananya, Archit, Bhavana, Chandana, Arshita. Today, no afternoon class is there, students. Sunday. So we won't take afternoon class today. Tomorrow I will take students. 14th group elements I will start tomorrow. 14th group elements I will start. Okay.